Hello there! Today's video is about a workflow that I find genuinely exciting. We are going to combine SubD modeling with CAD principles inside Blender using Sverchok. This hybrid approach allows you to keep the organic freedom of subdivision surfaces while introducing parametric feature-based operations, just like in traditional CAD systems. Before we jump into the video, let me show you a quick example. Here you can see a portion of a curved surface. This is a SubD surface with a creased border. On top of it, there is a cylindrical fillet. Now take a look at the smooth transition between these two elements. Let me bake this result and set it aside for a moment. Now imagine I slightly modify the underlying polygonal surface, just like this. If I update the surface, look at what happens. The smooth transition between the polygonal surface and the CAD cylinder updates automatically, without breaking, without artifacts, and without any topology cleanup. This is the core idea behind today's video. So without further ado, let us dive in. This first stage is just about shaping the overall volume of the Xbox controller using classic SubD techniques. I will go quite fast here. I am working with image references in the background and keeping the base mesh intentionally low poly. The goal is topological simplicity. A lighter base mesh means more flexibility later and fewer computational constraints once we introduce parametric operations. Here I am opening Sverchok and using a node called Approximate SubD. I input the base mesh, apply a mirror modifier, and generate a controlled subdivision surface. 2 levels are more than enough for this case. What we obtain is no longer just a mesh, it becomes a surface ready to host parametric features. This is where the hybrid workflow really begins. I will speed up again here. This is mainly a refinement phase where I am adjusting proportions, applying crease values, and carefully fine-tuning the curvature of the surface. Also, I am moving quickly because there are already countless videos online explaining SubD modeling step by step. You do not need another slow tutorial on how to push vertices around. You might notice that the reference images in the background are not perfectly aligned. They are not the best references in the world, and definitely not orthographic. But for the stage, that is perfectly fine. What matters here is not the technique itself, but what happened after. And this is the important part. Every modification to the SubD base propagates to the CAD features automatically, even creased edges. So when I tighten a corner or adjust a curve, the parametric elements adapt without breaking. The global geometry and the local features remain synchronized. That is the key idea. And honestly, that is where things start to get fun. Alright, from this point on there will be a bit more silence. You can treat this as modeling Asver. For the next few minutes I will let the geometry speak. Here I start with a simple cylinder. This will become the structural reference for the analog sticks and the directional pad. Nothing fancy, just a primitive used parametrically. Now the interesting part begins. I start applying Boolean operations to create the raised areas for the analog sticks and subtract the region for the directional pad. Notice something important. I am not touching topology. I am not inserting support loops. I am simply defining features. Here I duplicate smaller cylinders that will generate the button holes. Again, these are not mesh cuts. They are parametric volumes waiting to be resolved. In a traditional mesh workflow, this is usually the moment where edge flow anxiety begins. Here, not so much. This last button is slightly different. It is an elongated rectangle with rounded corners. I generate it using a fillet node and then select specific edges by direction, creating a mask based on vector orientation. Yes, this is slightly nerdy, and yes, I enjoy it. Now I create a node setup that collects all the button cylinders so I can perform a single subtraction operation. One Boolean, multiple features, still fully controllable. And finally, the moment we have all been waiting for. The node setup that displays the edge indices for filleting. We are still collectively waiting for Sverchok developers to bless us with a single magical node that does this automatically. Until then, we build our own tools, which honestly is part of the fun. Here I create an asymmetric fillet, wider on the left than on the right, just like on the original controller. This is where parametric control really shines. Symmetry is easy. Controlled asymmetry is design. And now, a very professional moment. I start looking for the original cylinders, and of course I cannot find them immediately. Because no project is complete without at least 30 seconds of existential confusion. Once I find them, I duplicate and transform them to generate the cavities for the analog sticks. Again, no topology adjustments, only feature manipulation. And here comes the final subtraction, one last Boolean operation. And that is it. The global SubD surface and the CAD features have been evolving together the entire time. No destructive edits, no manual cleanup, just curvature and parameters working together. Now we can enjoy the results. And finally, if you need a clean production-ready topology, you can simply apply an automatic remeshing algorithm. At this stage, the geometry is already resolved. The remesh is just a technical optimization, not a structural fix. This workflow gives you the best of both paradigms, curvature continuity from SubD and parametric precision from CAD. If you found this interesting, consider subscribing and leaving a like. It really helps the channel. I am genuinely curious to know what you think about this hybrid approach. As always, thank you for watching. See you in the next one. Bye.